Okay, I think everything's up and running. Okay, so Thunder, let me know the question, but I was gonna be working on homework. Oh yeah, this problem is weird. I don't know. No questions? Okay, it's a good thing. Um, you know what? I wouldn't mind looking at the book about Harnack's inequality. Doo, doo, doo. Okay, here it is. I want to know how to draw this Harnack chain. So we kind of went over it in class, but not very specifically. Ooh, what is this inequality telling us? The values of a non-negative harmonic function within V are all comparable. U cannot be very small or very large. Interesting. This is a short proof. A quarter of the distance from V to the boundary. Choose 2 points in the boundary that are separated to distance R. Then U of X is equal to the average value Why is that 2R? Maybe they just... I need to draw this. Where's my snipping tool? I think this will help me understand this. I'm going to bring in the question too. 1 second. Okay, but for now I'm going to focus on the proof of Harnack's inequality. So, actually, I want to draw it in the context of this problem. Never mind, we're not going to ignore it. So, U is... Oh my god, that's not a straight line. U is the domain that is like a square side length 1. V Okay, if I choose epsilon equal, let's say a quarter. Hey, 685, I'm doing good. How about you? Then one corner is at 1/4, 1/4. Yeah, it's PDEs. Epsilon to 1 minus epsilon. This is stupid that I have to do this by hand. It's 1 minus 2 epsilon. It just feels weird, the length. That makes sense, I guess, though, if I'm choosing 1/4. It's also 1 minus 2 epsilon in height. I should have drawn this bigger. Dude, I always draw things too small. And then I need to add in details. And I don't have enough room. It's like one of the best parts of taking notes digitally is you don't have to worry about how big or small you draw things. Well, at least how big. 1 minus 2 epsilon. V U so let's pretend this is the supremum in V. And let's pretend that is the inf. So according to this proof, we're going to define R to be a quarter of this distance here. So I think that's going to be 1 minus 2 epsilon divided by 2. Just that distance there. Hey Slim, have I considered getting a disco ball to make my streams more 7-tastics? I have not. That would be cool though. It's hard to see during the day, but that light behind me, it can do little like light shows, and that's why I bought it. But even at night, it doesn't show up very well. A disco ball probably would though. So that's a good suggestion right there. Groovy, indeed. That cancels. So we get 2 epsilon over 2. So it's just epsilon over 4 is that distance. Hope you've been doing well, Slim. The people are starving without your streams. It's been a month. Oh gosh. Some of your friends let you know that? Wow. Well, as long as you're taking care of yourself. Um, X and Y such that the distance between them is less than or equal to r. You are streaming tomorrow. You want to find the roots of polynomials using numerical methods. Ooh, cool. Yeah, because there's like bisection that you can do. Newton-Raphson. And Zach. Thank you for the raid, Zach. And McGurks. Thank you for the follow. I hope your stream was good, Zach. I saw you were doing a JE question. Which, you know, you did better than I would have, so my hat's off to you. Hey, Ren. We do. Peach Steve, I didn't say hi already. Hello. Yeah, I mean that that's why I stopped doing JE questions myself, because it was just like that every single time, and I kind of got over it after a while. Talked about Newton's method turned out to be using the proof of the implicit function theorem. I could. That sort of makes sense. I wouldn't have expected that, but I can see how that would help. Plus, apparently, everyone tomorrow Slim will be doing his first stream in like over a month. So go hang out with them. Hello, McGurks. Welcome in. Nihilist Mevlana, thank you for the follow. Those who are new around here, I'm Don. And Noob Exploded, the question is more or less on the screen. I'll explain it in a minute. So yeah, for anyone who doesn't know me already, I'm Don. I'm an applied math master's student. I'll be graduating in June if all goes well. When there's a question from chat, I work on homework problems, and the theme for the last few streams has been PDEs homework, because the class I'm in for that is kind of insane. And so I'm trying to. I guess we just completed our third week of classes, I think, and we've only been talking about Laplace's equation because there's a lot to talk about there. And I'm trying to think about this question about Harnack's inequality for a harmonic function. And I understand the intuition for why this is true, but I'm trying to understand the actual mechanics by going through this proof. In the context of this problem that we've been given. Hey, Suas. The idea is that you can describe the implicit function as a recursion that you can solve using Newton's method. Describe the implicit function as a recursion. As a recursion? Interesting. If you can fit it in a Twitch chat, you can send it in chat, or otherwise you can put it in my Discord. You can put it in Zach's Discord too and tell me where it is. But oh, Max, that is an average value integral. So if you have that below, I don't know, but I've done the same. It's gonna be easier to I'm just gonna do it in R1 because that's a little bit easier to describe. If you have this, that's equal to 1 over 3 minus 2 times the integral from 2 to 3 f of x dx. So it's just shorthand for average value. In this case, in multivariable, this would be the volume of the ball. Yeah, so harness equality seems like kind of a cool thing. It's telling you that a harmonic function, it kind of can't it can't undergo rapid changes, is what this inequality says. Like things have to be around the same scale. Yeah, exactly like that, Max. Oh yeah, so you should definitely sleep. Um, the unfortunate kind of catch is that you can't do it over the entire domain. You have to define like a sub domain and then it's valid. It also has to be non-negative. Um, yeah, there's like a cool thing where you use the proof is essentially using the mean value property a bunch of times. Like if if you're starting here and you're ending there, you just keep on choosing points and you create like a chain of like mean value property like disks or circles or whatever until you connect them. What I'm trying to figure out is exactly how that chain works. Like how do we construct it? Oh, what am I doing? You haven't seen this notation before? You always wonder what that glyph was in LaTeX? I've seen that before. Not too often though. Like I keep forgetting what it means. Hey Naman. Okay, let's see what what's this person's Nihilus Mevlana posted. The question is to solve it without using derivatives. Uh, this feels like a deceptively simple question. Like it's gonna be a lot more complicated than I think. Uh, what's up, Naman? And I think we're guaranteed E is greater than or equal to 1 because of this constraint here. That's interesting. So with 4 points, you can interpolate a degree 4 polynomial. With 3 points, you don't have enough information, but maybe this provides you enough. Um, I guess we also know if this does have zeros, they must be negative. I'm not sure if there's some symmetry that tells us that it can't have any zeros at all. They're probably not, because I think you could make something like x squared plus 1 times x plus 1 times x plus 2, and this might be an example of a valid p of x. I don't know. Well, actually, well, no, it's not going to fulfill these requirements here. Aaron, hello. Welcome back. Why did that get auto-modded? It's weird. Um, just the question on the screen right now. Apparently we're not allowed to use derivatives. Even if we were allowed to use derivatives, I don't know how. Do we want to consider like vertical shifts? Like, do we gain anything by thinking about p of x minus 1? Because we know that has a 0 at x equals 1. Yeah, so, sorry about that, Aaron. Yeah, Naman, for a degree 4 polynomial, you actually only need 4 points, in theory. And so I think this must be possible, given we have 3 points plus another piece of information. I just don't know how to use it. Actually, oh wait, am I making things up? You need 3 points for a parabola, and that's degree 2. Never mind, you probably need 5 points for degree 4. Yeah. Use graph. I guess that's... I guess that's an idea. Y equals x is right there. P of... Okay, we should actually... we would probably benefit from putting scales on this graph. Not just drawing things freehand. Oops. Yeah, when I it probably is something kind of vague like that. Oh yeah, A and S. I'm not doing that integral. Sorry. I'll pass. You are soon going to change your present line of work. You know what? Maybe Clonk. I don't know. I don't know your life. Right, Mevlana? AMGM? I don't know how to use AMGM. Which work? Points. Ooh, that's a thought, Slim. Happy weekend to you too, Clonk. Hope it's been going well for you. I'm not as high level of student to solve these questions. Aaron, I'm not high enough level to solve this question either. It's okay. have to be double roots. Yeah, that seems reasonable, Slim. What do I need to make this more general? I guess just a coefficient in front, right? Can we determine A just by plugging numbers in? Oh wait, no. I need to use P of 2. Yeah. Is equal to 4 minus 2 is equal to 2. And then on this side, A 1 squared minus 1 squared. So A equals 2? I'm missing an x minus x naught? No? Okay, good. It's like it's only to degree 4, right? Okay, and then we plug in 4 and see what shakes out. Nine, 18, 22? Oh, hey. I guess B. All right. Nice job, Slim, on noticing that. That turns out not to be a very long problem once you see that trick. Which is nice. Thanks for the question, Mevlana. Do we know this is the only P of X? Uh, I don't know how you would show it's the only one, but it sure feels like it is. I don't know how you would draw another Quartic that fulfills these requirements. Yeah, ANS, and I'm good. I'm gonna go back to this problem. Sorry, there's just certain types of problems that I'm not interested in, and that's one of them. I'm sorry, but I don't like doing insane looking integrals like that just for fun. Yeah, it is a lot of symbols, Aaron. Producing like 6 equations, math of it is blowing my mind. Could you explain? Oh, what's on screen right now? That's kind of a lot to explain. Um, or wait, do you mean like explain what I did here, Naman? Uh, ANS, I like Like differential equations, I guess, is like the the broad answer in like math by biology. Uh, I'm gonna worry because some people ask me that and then they start posting a bunch of challenge like challenge questions. Please don't do that to me. Like I prefer being a like a homework help type of person. Okay, that's like a better question. Existence and uniqueness. That's honestly not something that I know that much about, but we can maybe open up a textbook and talk about it. Like actually, let me talk to Naman first about this question that's on the screen. The actual proof for existence and uniqueness is apparently very long and technical, and I don't know it, but we can maybe say something about it. So, Naman, basically, the idea for this problem is you're supposed to notice that these 2 points lie on the line y equals x. And drawing it can help you see that. And so the point is, if we take our quartic and subtract x out, these 2 points become roots. I should maybe use a different color here. Of that p of x minus x polynomial. So that's why I was able to write it like this. And again, looking at the shape, 1 and 3 should be double roots because it bounces rather than crosses over. Yeah. And then once you have that, it's just kind of like plugging in the right numbers. Clonk. Example, x double prime equals x prime 0 equals I, x of 0 equals 1. Does existence uniqueness imply this is the only solution? Um, let me find my diffie-q's book. That's an interesting way of showing it. I'm used to seeing power series, and I've seen a proof that involves like derivatives. That's kind of clever. Called here it is. I assume this is gonna have existence and uniqueness somewhere. I think it's only going to cover it for first order. If math is your strength, what are you without it? I don't know, Lucas. Yeah, I'm a math solver myself. Sometimes I overthink the concepts that I have to apply in a question, make it overcomplicated. Just look at the answer. Any tips to get lazy while solving questions? Ooh. Uh, no, that's just like kind of the genius that can happen with math sometimes, like finding those tricks that simplify the work. it's hard to like. I don't have that myself, and even if I did, I don't know if it's something that you can really like give to someone else. Like I think you just need to remind yourself to look for those tricks before you go down some complicated thing. Well, that wasn't a website. This is just a PDF of a textbook. Hey Teja. I feel like when I was in high school trying to understand why triangles and angles are everywhere. Yeah. Sorry, Clunk. I know this is like really out there stuff. Which branch am I in? I'm studying at applied math. Aaron. Well, how to make it solvable first, and think of a theorem. Can do it easily. Right. It is meant to be a solution you should have studied. I'm going to practice to create a web of ideas. Strength set minus math. There you go. I don't know where to really apply the theorem, you know? As I just started getting into math, I was unsure about what operators you can really use without solving for x. I thought there were a lot of things you couldn't do. Oh, fair, Lucas, yeah? Yeah, competition math is definitely like that. Do they not prove this? I mean, I guess, are you interested in the proof, ANS? Because this does seem to fit the criteria of, or the differential equation you posted seems to fit the criteria that you posted. This seems too easy, to be honest. I thought there'd be some more requirements. So differential equation seems so satisfying sometimes, and also trig. Fair enough, yeah. Your dream will come true when you least expect it. That's a good fortune. If you have two solutions, yeah, that's exactly what existence or that's exactly what the uniqueness part says. If they look different, they must be the same. Hey, Skirt. See, that's a neat way of showing Euler's formula. So now you get a root can be a negative number? Sure. I. Well, wait, no. You definitely need complex numbers. So yeah, the Wikipedia page for Euler's formula has 3 proofs. None of them are the differential equation one, I don't think. No. So that's a neat 4th way of doing it. Equations are the equivalent of algebraic thirst traps. Freshly baked warm cookie, anything good works. Geometry complex number is fun to do. Yeah. Sounds good. Aaron, sleep well. Can you calculate when I can start eating again? I hope it's soon, Skirtle. I'm sorry. That would suck to just live on liquids. It's not really a true way of finding a negative root. You'll be the guest of a gracious host. Ooh, that's a good fortune. So yeah, I guess Lucas, like, we kind of all agree that the square root of a number is always positive. There's no reason we had to do that though. Everyone could agree that the square root of 4 is -2. It might leave some weird things that would look different, but I think you could define it like this if you felt like it. I don't think it'll lead to a contradiction. I shall crash your apartment. You will bake cheesecake for me. If you actually came to America, Skirtle, I would bake you a cheesecake. It's a really easy promise to make. So, you know, it's probably not going to happen. Any stuff like complex numbers of dual numbers or such. You can plug in a number and get a negative number for a root. Also, yeah, underscore. I forgot to say hi to you, but I think yeah, hi underscore. Um, sorry, I'm trying to think. So like, there's like a okay. Shout out to Zach. E to the 2I pi. If you take the square root of this, so wait, actually, let me back up. Why is a Kendrick Lamar song in here? I don't mind it, but that's very random. Anyway, so e to the 2I pi is -1. Sorry, it's +1. If you want, you can verify that by using cosine plus I sine theta. Dawn of the Dead. Nice. I should actually watch that movie so I can make jokes about it like that. Oh, you know what? When I was changing my name from Don Does Math, I actually considered that. I think it's taken though. So e to 2I pi is 1. But if I take the square root of e to the 2I pi using exponent rules, which there's some subtlety here. Like what I'm doing is like I think slightly wrong. But you can say it's equal to e to the I pi, and that's actually equal to -1, which is another thing you can check with Euler's formula. So I guess using complex numbers, yeah, you can take square roots and get a negative number out. It means something else in your mother tongue? Oh. Lucas, okay. It's funny. For the square root of a complex number to be real, t must be 2 pi I k, or 2 pi k. If the root is complex, it cannot be negative. Hey, color cone. We can only look at the case where r8 to the 2 pi ki, where r is greater than 0. What about Dawn of the Deadass? That'd be a hilarious name. I wish I thought of that. Hey, Cook. I'm doing all right. You know, just stressing from school and stuff, but the usual. Hope you're doing well. An imaginary exponent's properly yet. We haven't proved its normal exponent properties hold for complex. Yeah, I mean, that's why I'm saying this is slightly wrong, because like there's like a branch cut thing that I don't want to get into. How's the meth today? It's going all right. I gotta start on the PDEs homework, and I actually could do a chunk of it. Without too much trouble, which is progress. Here's something you find cute. I equals capital I? Wait, Is that I equals e to the pi I? E to the pi, or like find an, oh, but I equals e to the I pi over 2. So you could say, yeah, so you can do this. That is kind of cute. Yeah, yeah. I like that. It's like tetration. No worries. Math is like meth to me. Recently started seeing videos where people incorrectly claim that I to the I is e to the minus pi over 2. Oh, I've worked that up before. I forget what I got. If I do your homework, will you play Fortnite? Girl, if you can do my homework, then yeah, I'll play Fortnite. LHS is purely matching RHS is at least superficial. Yeah, because it looks real. That is cute. Okay, so e to the I pi over 2 to the I. And then presumably that's e to the minus pi over 2. What did Pui say they were getting? Oh. Is that wrong? It's because of that step, I guess. No guarantee it's all correct. Yeah, if you're just gonna feed it into ChatGPT, I can do that myself. But using logarithms doing principal branch. Yep, so I honestly thought that this was correct. So if you want to correct me, please do. Skirt GPT, you and your drugged up brain. The base of e to the z is well defined even if c is complex. You still have v to the z. Right. What if you use 5 pi over 2 instead? Oh, true. Yeah. Okay. Fair enough. I guess you do need the like plus 2k pi. I think you noob exploded. 20. No, I don't think they've graded the PDE homework yet. Okay, Skirtle. I was confused if that was going to happen today, but I started my stream early in case it did. Enjoy your nap. I don't know how I would wake you up, but I'll try. So yeah, Carcon, I don't think that they've graded it yet. And even worse, the professor just said yesterday he is morally against putting out solutions to homework assignments. So that's that's an interesting take. I know exactly, Dr. Cook, and I feel like one of his problems isn't even impossible. So he told us we should all be sharing our answers with each other. To figure things out. 0 2 is a rational number. The square root is an integer. Is pi to the pi to the pi an integer? I doubt it, Tio Mac, but it's hard. I'm sure that'd be hard to prove. Doing my board exams right now, watching complex numbers instead of studying English literature like a good boy. I feel that, ANS. What is the problem? It's that problem that we were talking about a lot. Here, let me. What did I just do? Okay, it's fine. Let me bring up the work for last homework. So I went to the office hours for the TA, and she did the problem, but I think there was a mistake. I turned it in anyway, just so I had something to turn in. but I feel like it's not right. So it was this problem here about the differentiability. Oh, this was updated. It's these Lipschitz continuous. This is an old version of the question, but he did change it so that phi is Lipschitz continuous, which does help, sort of. Oh, I didn't write it down. So yeah, but we know that f is in ck, and the first step that I think was invalid. Take the kth derivative of the convolution. I think it's not valid to bring this derivative inside of the integral. That's what I think is not valid. So I think you need k plus 1 derivatives of f, don't you? Because I thought for the Leibniz rule, you need the next derivative to also be continuous, and we don't know that. Like, f would need to be in ck plus 1. Complex variables, I to the I equals e to the... Okay, fair enough, Puika. I can understand that putting out solutions means people might cheat next year if he doesn't change the problems. I don't see how it's a moral issue. It's because it's like he said there's no one canonical way to solve questions in math, and that was a big part of his argument. Like, thinking that he's going to be like reducing us into just one type of solution for a problem, but like, I really don't agree with that. I'm so bad at all this official math talk. If I see something in notation, you do understand everything. Oh, I mean, that's not bad though, Lucas. What's uni like? I mean, for me, I'm a grad student, so it's pretty brutal. With AI, people basically have solutions before AI. Chegg and solution manuals were trivially easy to find. Basically, worth 15% grade just for turning in a reasonable homework. Give them the solution to one problem. Tell them to come to office hours for their solutions they want. No one comes. I'm kind of surprised. I mean, I guess undergrads, I assume you're teaching undergrads. They probably don't care as much. The office hours for my classes are usually pretty busy. Like, the room sometimes gets at capacity with like 8 or 9 people. What the hell is a compact metric space? I can only sort of tell you. It's like a bounded interval is how I think about it. Like 1, 2 is compact, inclusive. Good luck, ANS. Sorry guys, I'm doing my best to keep up with the chat here, and I'm not doing a good job. Convolution got whatever regularity the highest function have, as long as the other function is not super bad. Well, yeah, but I thought that the Leibniz rule, you need f to be k times differentiable, but also k plus 1. I don't know. If it is right, that'd be great, because then the solution to the answers is, I think, just right. But I didn't feel right. To analyze 3 books, 15 poems, do it all for... Oh god, ANS, it sounds terrible. I was doing 2, I got like 2 to 3 regulars. If they don't come for some reason, you get empty office hours about a third of the time. Fair enough. I mean, as an undergrad, I almost never went to office hours, but I didn't usually have much trouble with my classes. For masters, I'm going all the time, like multiple times a week, but... Okay. I don't think you need it because of the compact support. Probably still use Lebesgue, BDSM theory in interchange limit. Really? I don't know. He's beaming. He's talking about the dominated convergence theorem, but because of the word dominated, it's fun to call it the BDSM theorem. when you're really paying is different. Yeah. Undergrads on loans are paying. Yeah, and they're still getting like a lot of support from their parents usually. So it's it for a lot of undergrads, it just feels like an extension of high school. Like they're going there because they're expected to go there, not because they have a specific goal that they're trying to achieve. Interchanging sum and integral, it might also work for that, but you can definitely use it for limit and integral. Yeah, Pui. That was just the first step, showing that if f is in CK, then the convolution is also in CK. To prove it's in CK plus 1, the next step was to find the derivative of that, and then prove that that derivative is continuous. And then that's how you show it's in CK plus 1. But just like the first step of showing the convolution is in CK. Well, yeah, so that's the problem, color cone. I thought. So the partial is dk plus 1, and we don't know that that's continuous. I thought. No. Well, I mean, it's just gonna. Like, I know it's gonna end up just being the convolution of like phi with the derivative of f. Here, look. Let me bring up my actual assignment that I turned in. Okay. Actually, wait. Let me zoom in a bit more. Okay. So yeah, important modification. Phi is Lipschitz continuous. Um, it's definitely true, Puika, if phi is smooth. That's actually pretty easy to show. But we aren't given that phi is smooth. Lipschitz continuous is close. It's basically Lipschitz continuous seems like an analog for pointwise smooth. Um, but I'm in this case, I'm not sure if it is true. Um, so yeah, ignore this first part. This is where the part that I'm talking about starts. So I did it anyway, just so I had something to turn in for this problem. But I want to say this step isn't valid because I think we would need the next partial of f to be continuous, and we don't know that. It's first derivative in L2? Okay. But yeah, I mean, the Wikipedia page for Lipschitz. It's differentiable everywhere except it's differentiable almost everywhere is implied by Lipschitz continuity. There. Um, but yeah, for my reading of the Leibniz integration rule, I think if we want to interchange k many derivatives, we need k plus 1 many partial derivatives, and that's what I think we don't have. So maybe I'm wrong, but like down here. This is basically me repeating what the TA did during office hours. So I'm not like a, I don't know why it's fine, but okay. Theorem only requires the partial be continuous. Oh, I understand now. Okay, my problem, I was mentally counting from 1. I should have been counting from 0. This is like F0, it's not F1. Okay. Thank you. I get it now. Okay, I have no problem with this proof then. I feel like if I knew that, I could have done this problem myself. I just thought this wasn't valid, but I don't know how to count. I mean, okay, maybe doing it myself was a little bit strong, because I had no clue that this theorem even existed. Okay. Let me close out of these tabs. Okay, but yeah, so yeah, this is the new PDEs homework here. Yeah, DK plus 1 would have been an issue for sure. Um, so looking at the one about Harnack's inequality, but actually, you know what? I did. I wanted to. Okay, so color cone. I mean, you don't have to answer this if you just don't feel like it, as always. But like for this problem too here, I already did the first part. It's kind of tedious, but it's not so bad to take all those derivatives. For the second part with the limit, I can't get the 1 over pi factor to cancel out. And I'm wondering if I'm missing something about like the delta function. And I just want to see if you happen to like know something. Because like my issue is I'm getting 1 over pi times f of x, and I should be getting just f of x. No worries, yeah. Because it, like, problem one is really similar and ended up with the same, like, issue. I thought this limit was kind of fun to take, like, figuring out that the delta function is even involved here. Convolution with a fundamental solution. Uh, yeah, I think it's a fundamental solution for the upper half plane, and the yeah, it's just a convolution. Delta G is Dirac T0. Uh, what is G? Oh, Green's function. We haven't talked about Green's function. But yeah, I think this is a Green's function. Probably. From what I remember about how they work. So yeah, there was a like the first problem was basically the same setup. Uh, but with the unit disk and this Poisson kernel. That's just another like convolution. But I have the exact same issue where the limit works perfectly except for that 1/2 pi factor not getting canceled. So I must be missing something about like the delta function, I think. But I looked at the Wikipedia page and I couldn't see what. Yeah, same issue here. Yeah, like I don't think the delta function, like I'm pretty sure this property doesn't involve any multiplications by a constant. So, but I also don't know where else it could possibly come from, if not the direct delta function. Yeah, it's using like this, like the first and last equality here. So I remember learning about that during the complex analysis class. Oh yeah, sure. I mean, it is possible that I did this limit wrong, but I thought I did it right, where it's almost always 0. except in like one special case where it blows up to infinity. So I just recognize that as a direct delta function. I looked at this Wikipedia page too. That matches, right? So the problem seems correct. That's good. The Wikipedia page even says a radial limit that agrees with f almost everywhere on the boundary T of the disk. So it must be, there's no citation, unfortunately. Hey, Ayush. What if I Google it, though? Can I find someone else who's computed it? Right now I'm Googling things in the background. How did I get delta? So I noticed this limit is always 0, except in the special case theta equals t. I think for any other value of theta minus t, this limit is 0. But other than that, it's infinity. You can have scaling. Oh, that is the thing with the delta function, right? It doesn't care about scaling. Like, it's like, is it delta of x equals delta of 2x? Is that the property? Can I just make it 2 pi to make it work? Or maybe 1 over 2 pi? Let me, I need to look at the Wikipedia page. Like, this property is probably listed somewhere here, right? Oh my god. Wait. So can could I have just said 1 over 2 pi times this? And it's the exact same thing, but it gives us the constant that we want. think that feels like it must be that. How do you show the left factor in the integral goes to that? Uh, I mean, I didn't specifically write it, but I just basically thought of this as like a piecewise. Oh my god, what a terrible curly brace. It goes to infinity when theta minus t equals 0, and 0 otherwise. And that's just the definition of the delta function. But, like, this doesn't matter, I guess. Oops. Like, it's still 0. Two delta x. Yeah, I mean, I'm saying we could do any multiple we want. There's just one. I mean, okay, so you're saying that we could get any answer. Like this presents a problem. Okay, I can't just make it that easy for myself. Well, I don't know how we show this limit goes specifically to like with the scaling. Um, you're gonna be a linear combination of direct delta function and its derivative. Hmm. The test function to see what it does when you integrate it. Well, I can see how like the problem with what I'm saying is I could also have gotten 2f e to the I theta or a third, and these can't all be equal to each other. So I guess there is like one right answer, but like how do we? I don't know how to show that. Like, do we need to set up delta of some alpha times theta minus t and somehow figure out what alpha is? They did separate the parts for t away from the theta and close to theta. The first part converges by dominance. For the second, you use some bounds. The f's value is close to f at t. Hmm. So, okay. So yeah, I've definitely seen like you can express the delta function as like the limit of. I mean, there's a lot of different choices of delta functions, but like maybe the easiest one to work with is like it's like the uniform distribution, but there's you have to get the scaling right. Do I have to somehow match that definition with what I have here? Hey Leo, do you guys know about alternating quantifiers like exist for all, and is there equivalence with two-player games? I know about like there exists in for all. I don't know what a two-player game would be. Okay, yeah, like this is the one that I'm used to. I think those epsilon goes to 0. It's just a way to think about them and gonna make a video on them. Ooh, it's cool. You gotta use classical notions of convergence lightly. That's fair. Any order that exists for all statement is a two-player game is equivalent to which player wins under optimal play. I guess and thinking specifically about like epsilon delta proofs, Leo, I could sort of see that. Where like player one is giving an epsilon and player two is finding a delta. Is and like it's true depending on whether or not player two can find that delta. Okay. That's a nice way of explaining it. Um so when t is away from theta, this it's gonna be 0. But when t is close to theta, what the hell happens? Minimax condition be lucid this way. IMO. Going back to sleep. All right. Thanks for sharing, Leo. Sleep well. Um, how to express this succinctly? When t well, I don't know how to do what Pui is saying is my issue. Like uh yeah, I guess I'm getting I'm also getting stuck on the bounds. It's I should be able to write it in just one bound, but I can't easily figure out how to do it. So let's just do it the stupid way. This is the part that's going to get bounded. Or rather, this is the part that's going to go to 0, is what I mean. And I'm just being lazy and not... The integrand is the same in all of these integrals. I just didn't want to write everything out. And actually, Hui said that the first part converges by dominance. Should I not even be bringing the limit inside the integral in this piece? Because we're not sure if it converges? You replace f values close to t with a value at t plus an epsilon error. But doesn't the epsilon error depend? I guess we're bounding it. Like, this is going to turn into a less than or equal to? I guess I already used epsilon. Alpha? I don't know. But I think this inequality is bad. Hey, Aeneas. We could make it exactly equal if we let alpha be a function of t, but I don't think that's good either. That doesn't feel like progress. So yeah, I don't understand the idea, I guess. We do know that f is continuous. So as epsilon goes to 0, it is going to converge to the value of f at theta. I don't understand how we're getting closer to the delta function, though. For theta minus t equals 0. Hey, Handle. I'm doing good. How about you? Or I guess, yeah, for theta equals t. SB? That sounds familiar, Handle. Consider the integral on t minus theta less than epsilon. Well, yeah, I mean, I don't like putting t in the bound, but that's basically what I was trying to write with these three things here. But yeah, but like, I know that's what we want for the bounds, basically. Um, I just don't know what happens after that. Hmm. Yeah, and the one that's greater than epsilon is 0. The one that's less than epsilon should give us our delta. Suppose to assume it's equal to 0 when you prove the limit is 0. For any epsilon, choose delta. Quinner, thank you so much for the prime 8 months. I appreciate you, dude. Hope your Saturday is going good. For any epsilon, choose delta such that for the limit is 0, for any epsilon, choose delta such that for t minus theta less than delta. The integral into 2. Okay, I don't want to use t in the bounds of an integral though, but it's going all right so far. That's what I'm trying to like avoid because it's just not right. Wait. Okay, I'm getting confused for another reason. The limit is in R, but we're doing a different limit with t. Uh, on the latter, it converges to 0 by dominance. The second is bounded by epsilon. The integral of the kernel is 1. Is it? I made a mistake in a different problem then, because I thought it was 0. If you integrate, like if you scratch out the f part, I need to check my calculations then. So yeah, Pui, I don't understand why it's bounded by epsilon, the second part. And you're saying it has to do with um the kernel integrating to 1? Equals 1 should imply u equals 1 by uniqueness or maximum principle. Yeah, I know the point of this is that the values should match. This way that we can check that this, it's like a sanity check that this kernel makes sense. And also, even if it is bounded above by epsilon, how does that? I'm sorry, I also don't understand how a 2 pi gets involved. So yeah, I'm sorry, Pui, I'm just not following your argument. Like integrate them. Oh yeah, so if you scratched out the f and you scratched out the 1/2 pi, just that would be 2 pi. Yeah. But with how I've written it here, at least that's helped me try to figure out what Hui is arguing. Um, Yeah, I mean, I'm not that good with Fourier series, but like I would hear if you want to say it. I don't understand how the part. Let me where t minus theta is less than delta. How that's bounded above by just epsilon. I don't know where Pui got that from. One over 2 pi and minus pi to pi. Probability t dt. PR and 1. The L2 inner product. Is that just PR? Oh, Poisson kernel. Why is it PR? That makes no sense. Okay. Oh, P sub R. Oh, that makes more sense. PR is written as a Fourier series. Hmm. I don't know. In parts with one, we'll just read the first coefficient. Oh, is this like is your one here just like a uh it's a basis vector like 1 0 0 like that? Okay. No? Or is it a vector of ones? Yeah, I definitely don't understand what you're writing with that. I thought these were scalars to be honest, so I don't even know. Oops. Oops. Should I have thought these are scalars? I guess I shouldn't think. Well, it's a complex function. Well, it's not. It takes a two-dimensional input, but the Poisson kernel is one-dimensional in the output. Hey, Obi. Hope you're doing well. I n theta for n and z. How goes the PDEs? It's a lot of suffering, but it's going. There'll be the first midterm in like 2 weeks, and I'm very nervous for how that's going to go. But if I can manage to do well on that, I'll feel a lot better about the rest of the class. Got back from shopping, feet happy not to be used. Fair enough. It's always great to not have to use your feet. So just take epsilon greater than 0, choose delta so that when t minus theta is less than delta, f of e to the it less than epsilon. And okay, so we know that f of e to the it, that the epsilon exists because f is bound or is continuous. It's also bounded. Uh, so the thing we're really doing here is taking the limit as t approaches epsilon. That's been my confusion, because it doesn't make sense to me to split an integral in terms of t. That's part of the thing that I've been stuck on. Like, it's definitely not valid to write the integral literally like this. And so I think I know what you mean, but I think this is like more correct. Like I don't want t to be in the bound and also the variable that we're integrating in. That's why I haven't been writing that. It's just t. We're talking about like the limit part right here. I did the problem nearly right on my own, but I messed up. There's something subtle about the delta function here that Pui and Color have been trying to teach me, but I haven't been following yet. Replace f by 0 up to an epsilon error, and we're just assuming that f is 0 at this point. Contributes at most epsilon. Kernel is total mass 1. Wait, Color, you're saying it does make sense to have t in the bounds? Okay, well, this is the equivalent thing of I should use the letter delta instead to match what you guys are saying. But like this is the same thing. If you have a function f and L2, you want to know its an coefficient. Oh, right. Carlicone. I do remember that about Fourier series. Okay. I'm just gonna say this is shorthand for basically that, but instead of epsilon, use delta. Because you two just seem to enjoy that. And then the flip side, this is shorthand for this, but with delta instead of epsilon. This contributes at most epsilon. Just bound f. Okay, so on this inner part, Yeah, and so Pui is saying to call fe to the I theta just 0. I'm just going to call fe to the I theta. But, like, I'm worried about this being an inequality. Like, and I can see from here, um, this shebang integrates to 1. We take the limit as epsilon goes to 0, and we get just fe to the I theta, but this inequality messes up our desired result. We've only bounded it. We haven't actually shown exact equality. Denominator is just re to the I theta minus e to the it squared. The magnitude of that squared. Huh. Int f of t greater than epsilon? Oh, that's terrible. That I hate that even more. Okay, well, and the second part just bound f. Oh, okay, so in this case, the kernel integrates to 1, but then in this case, the kernel is going to integrate to 0. I don't know. I still don't like this argument. I'm sorry. This less than or equal to, I think, messes everything up. Like, we don't want to bound. We want equality. And it's probably me just not getting it. I'm not saying that you're wrong, but I don't really know what to do with this. Well, it's not about bounds when they're asking us to prove inequality. I'm okay with bounding something when the question is to bound something, but they're not asking for an upper bound. Like, I don't think this argument answers the question as I understand it. I mean, I guess that would make it better if we include some absolute values also. But what if it's not 0? Okay, but what do you do if it's not 0 though? Like, what would you address that by uh just doing like a vertical translation, I guess, or like subtracting a constant? Hmm. I don't know. I think I need to sit on this. Like, I'm not saying you're wrong. There's just something about this that I'm not comfortable with still, but I don't know how to say it. Hey, suck now. Okay, well, we can go to a different problem instead. So I'm gonna have the same issue with this second problem, but I'll work on that another time. Um, so this is like three problems in one. It's actually related to what we were just talking about here. So this calculation is going to be useful for the thing that we were just talking about. For the first sentence here, we have to actually calculate the integral of the kernel. And I got 0. And from what we've been saying, that's wrong. So I should um check this work, I guess. Proving x equals 0 same as proving the bound x less than or equal to epsilon for all epsilon. Yeah, I guess it's fair. We. You make the integral as small as you want? Isn't the integral just always 1? We're shrinking the domain? Then I understand this argument even less. I'm sorry. If this isn't equal to 1, I don't know what the hell any of this means then. So before we actually evaluate anything, we need to combine them back? Chandu, it kind of depends, but sleeping on it can help, just like or taking a break in general. Asking for help at office hours. Or just skimming through like a textbook or sections threads that you think might be useful. Could like jog something. Yeah, that's fair, Color Cone. I understand that now, but so but then we're splitting up the integral and then putting them back together again, and it just I really don't understand this argument then. So I thought we were relying on the integral going to 1. But we do need the entire domain, like you're saying, so like why are we splitting them up if we need to combine them back? I guess just to demonstrate that we only care about one piece of the integral. I don't do leet code. Yeah. Fair. I I don't know. I wish that the delta function argument just worked, because I really like that argument. Although it obviously doesn't work the way that I did it. Um, it is depressing. You're right, Lucas. Uh, I don't know, but sad music has its place. Math cannot be this bad. It can be pretty bad. Oh yeah, so I think I deleted my work. Did I? Oh good. Here's another sad song. Um, so yeah, I mean, this question feels very fitting because this is like I'm gonna need to show that let the kernel integrates to 1 anyway for this question. Um, this is Radiohead. This is I haven't listened to that much Radiohead, but this is my favorite song by them. It is super depressing though. It's also very like moody and like angsty. Karma Police? I couldn't tell you a song by them. Radiohead is kind of weird as a band. Like, I don't really get their music. So yeah, I used Wolfram Alpha to do the actual integration because I'm not going to integrate what amounts to 1 over 1 minus cosine. And this is a much more complicated version of it. But Wolfram Alpha gave me this for the indefinite integral. Oh, is Karma Police a song? I assumed it was a band. Karma Police. Oh, it's a Radiohead song. I've probably heard it before. I just don't recognize it by name. All right, we're playing that. Simple trick. Oh, really? I would love a simple trick without computing the integral. Please tell me. Well, well, let me show you what I was doing to prove that the Poisson kernel is harmonic. For the first part of question 1, they asked to show that it's a harmonic function. So I calculated these derivatives. And I did it right. I didn't make any major errors. And all these terms do cancel when you plug them into the Laplace's equation in polar coordinates. F of e to the it, it's just so if you remember Euler's formula, e to the it is cosine t plus I sine t. It's just a shorthand for a function with 2 inputs, like the imaginary or the real part and the imaginary part, basically. So it's a function that takes 2 things as inputs. These inputs happen to be related, but that doesn't matter. And it gives you a single number out. And complex numbers are just like a shorthand for that. I once pulled a song off of the college's torrent that I thought was going to be Guster. Turned out it was a band called Hooverphonic. There's a song by the same name. Still have it. Oh, nice. I want to say, Hooverphonic sounds familiar. I think I've heard a song by them. I don't remember what playlist I have it in, though. Oh, I remember the name of it. Is it... Yeah, Mad About You is the one song of them that I know. It's a pretty good song. They're Belgian. Oh, cool. Yeah, it's basically a 2-variable function, Lucas. And complex numbers are a really like convenient way to encode 2-variable functions. In this case, it's not any two numbers, it's specific pairs of 2 numbers that are valid to plug in, but yeah, it's still 2 variables. I remember this song. I've heard it before. Right. Minus infinity to infinity. No pi? Because theta's in radians. And I. Blue Wonder Power Milk? I don't think I've heard that song. How does integrating like this work? Gusser's Eater. Oh, okay, interesting. So yeah, Lucas, when you have an integral with I assume you're confused with all the different letters that are inside this integral. You only pay attention in this case. Let me show the original. Oh, like looking at, well, no, I won't look at this. The integrals in terms of t, so you only care about t, pretend all the other letters are constants, is the basic answer. So this integral here, you could think of it as really similar to integrating 1 over 1 minus 2 cosine t dt. Or you know, like something like this. TVSR, that's true. There's a question I cannot solve. It's my claim to fame. If you give me a problem, I can walk away from it. Welcome in. No worries, Lucas. Yeah, this is a type of integral called convolution, which is, it's really cool, but it's really difficult, and it's kind of deep. It has some really cool applications. It's basically like you're combining two functions into a new function. You solve the voice in your head? Unfortunately, that's one of the problems I cannot solve. So do a simple exercise so you can get the feel for that kind of trick. Sure. Thanks for the follow, TBSR8. You very much enjoy integrals because you find them very easy, or relatively easy. That's fair. Integrals are very deep. Ugh. 3B1 Brown is a pretty cool video on, he has 2 videos on convolutions. So if you're interested in finding a type of integral that you might not understand at first, let me see if I can find it. This is for discrete. Okay, yeah. This is the video that kind of goes into what a convolution is. And I'll catch up with, or actually, no, I'm not behind on chat. I know basic algebra and arithmetic, bro. It's like Chinese, some fun to watch. Hey, well, welcome in. I'm glad to have you. So yeah, for background, I'm a master's student studying applied math. And so I don't mean for the stream to be this complicated, but until I finish my degree, a lot of the stream is kind of filled with the homework that I'm doing. We always, yep, it's exactly that. I'm always happy to talk about, like, if you have a question, I'm always happy to talk about that. But if there isn't a question, then I do homework, and that's where the really complicated stuff comes in. Yeah, and so to try to quickly answer your question, Lucas, convolution, we denote it as like a function star or asterisk, another function. And this is a function, this new thing, this convolution is a function of x, and it's defined. You can define it a little bit. It doesn't always look like this with these bounds, but just to keep things simple. Phi of x minus y, f of y, dy. And this form probably doesn't make much sense when you see it at first. But the integral is in y, and then this x is gonna like emerge from the integral and only involve, like, this is only going to involve x's once you actually compute this integral. This has a really cool interpretation that's hard to explain quickly. But it turns out like, yeah, phi, Greek letter phi is just a common name for a function in this context. It doesn't have to be phi. But it turns out like this shows up in probability and differential equations. And probably in other contexts too. It turns out to be kind of fundamental in some ways. And you can use like if f is some really like one of the applications, if f is some really like rough function, like it's real world data, you can choose phi that's like some smooth function, and when you compute their convolution, you get kind of a smoothed out version of f that's easier to work with. So that's like one of the ways you can use a convolution. Yeah, it's a really neat thing, I think. So yeah, sorry for putting what you're saying on the back burner, color cone. Same with you, Obi. Been a tutor for how long? I that's always been a weird thing for me to answer, because I've only been a like my job title has only been tutor for officially for like 6 months of my life. But that's fair. I've been like informally tutoring friends since high school, and then I've been doing this stream for over 3 years now. Can you explain what is an integral? Yeah, as Obi says, it's basically the area under the curve as a function. I can draw that in a second. Actually, I can draw that now. So if you have some function f of x, the integral, which is like this stretched out s, let's say from 1 to 2 of f of x in terms of x, which don't worry about this notation, means it's the you take this graph for f, and from x equals 1 to x equals 2, you find this area. That's fundamentally what an integral is. A Riemann integral, I mean, even other types of integrals too, I think. It's defined as the area under a curve. That's what the summation, like f of x sub I star times delta x. I'm getting the definition slightly wrong, but like you can formally define integrals as a summation of area, and that is the typical definition. Okay, sorry, color cone. Let me see what you're saying. So that means you can write f as a Fourier series. F equals sum n a n e I n theta. When you compute the inner product of f comma 1, tell me how this relates to the integral of minus pi to pi f. What is the value of the integral? Oh, right, inner products. Oh my god, I'm thinking of vector inner products. Thank you for defining inner products for me. F bar G. Not another super depressing song. Sorry. What is bar G? And sorry, complex conjugate? Okay, okay. Oh, right. Okay, so sorry that I'm getting so distracted. Color cone. Um, and then we know, so G is just 1, so it's just F, but then we know how F looks. Um, and Lucas, I'll talk about that in a second. Um, for Fourier series, I we I assume we need this property. Isn't an equal a minus n? We might not need that property. No? Okay. I don't know where I got that from then. And so I'm certain that we're going to get. I know the answer to this question is that it's going to be a sub 1. I'm trying to find where the cancellations come from though. Can we just interchange the sum and the integral? I forget when you can do that. I'm just well, it's convergent, right? So we can that's we're allowed to interchange them. A n I n I n theta minus pi to pi. Uh, easier conceptually to compute. Yeah, something about this doesn't feel right. Okay, wait, let me read what Luke's question is. If that's the Riemann definition, how do you show this is indeed the area under the curve, not just another weird thing like a Pythagorean theorem false version? Never learned what easy English is? Oh, that would be hard, yeah. Um, I mean, so it's we just agree. So like it's the area under the curve by construction, Lucas. We constructed it specifically so it is the area under the curve. Um, so to a certain extent, it's kind of like it's that way because we all agree it is. But this is just like this is the height of a rectangle and this is the width of a rectangle. And we're adding up a bunch of super thin rectangles that are defined by this function. So like the answer for why this is the area under the curve is because like just look at it, I guess. And that's a crappy way to answer the question. But there are functions you can throw at this that do break the definition. And it's still a really good question for that like or it's a like you're asking like a really like good question because you can find functions that well they don't break the formula but the formula stops being helpful, like it doesn't give you any meaningful information. So just because you can do this doesn't mean you should do this for every function. Um, I mean, you could think of it like that. The thinner you go, the better these rectangles approximate the area. So it's almost like we're saying not even necessarily linear, but constant even. Just like a horizontal line, not a diagonal line. Like that's how narrow we have to make our rectangles until that's approximately true. Yeah, I'm sorry, color code. I'm trying to. Um, follow two interesting threads at once. Uh, you can bring the summation outside of the inner product. I had no clue that was possible. Did I tell you I figured out where I'm moving? Oh, no. Where are you moving? I forgot you said that before. Okay, inner product of... And so this is... It's always going to be 0, except when n equals 0, I assume is the point. From Puerto Rico to the Connecticut and Rhode Island area. Huh. You don't have to say if you don't want, but like, did your parents get a job in that area? Or if you'd rather keep it to yourself, that's fine, but I hope that you end up enjoying it there. But I know that like it's not a comfortable situation. So I hope it um I hope it goes well. Um well, the sum is on the outside. Oh yeah, okay. Is this it? And I'm thinking of 1 as the same thing as e to the 0. There's a proof like deep in the rabbit hole of integral theory that an integral eventually becomes the area under a curve. I wouldn't say it's deep. I'd say that's the first thing that you learn with integrals normally. That's how we define them. Like that's the jumping off point to do other things with integrals. Um, I don't have a good resource for it. Maybe the Wikipedia page. Like if you just like look up a Riemann sum, you should find explanations for those. I wish this link was working. um, but yeah, so like Riemann sum is the thing that you'd want to search here. Everything died in the sum except the first coefficient. Right. So you get A0. Right. It's 30 inside rabbit hole from the bat. That happens a lot too, Raven. Yeah. Oh. Yeah, I was looking to see if Paul had a good explanation. Um, yeah, as Obi says, I think there's something tricky about defining integrals that way. You probably could just define it like that. The way that I'm used to calculus being constructed is you start with this. And you end up with the fundamental theorem of calculus, which is what says that they're inverses. You might be able to do it the reverse way, where you start with inverse of a derivative and get to here. I haven't seen that, though. What have we computed in terms of the integral? Okay, well, I guess now we go also to the definition of convolution. We know these two things match up. Yeah, Lucas, I feel like that's another thing where we commonly define something in terms of an inverse, but you don't have to. I can't remember what. Yeah, I don't remember. Riemann integral, you're saying you can't do it as an inverse. Hmm. I if f is differentiable, you don't think f prime is Riemann integrable, or like I guess. Oh, if like maybe there's like hmm, like if you have a x to the 1/3 type of situation. I'm sorry, Sock. No, I saw you said that and I got distracted. Parents being relocated that way, it's gonna be another Hispano ministry for them. There's a disaster, some church drama. I feel bad for my community, like it's just gross the infighting. So I'm moving that way. My parents have to clean up the mess. Oh, okay. Well, Sock. No, I hope it turns out to be a positive for you. But yeah, that's gonna be a big change. Oh, Fizzbuzz. Sorry guys, I'm doing a really bad job of keeping up with chat today. There's something about adding the ocean. Keep hearing about people saying plus C. True. For Lebesgue integrals, it works. That's fair. That's why I'm moving. Oh yeah, okay, I read that. The math teacher asked us an integral bonus question on our test about derivatives. Oh, I mean, there's a question there you can probably like make work, but it depends on the question. You almost snuck that by without being noticed. No sneaky puns here. They get called out. For the Beckett. Okay. Yeah, so that's what I'm saying. There's probably like a some exceptions or some like caveats you need to add, but like being sort of the inverse of derivatives is like that's also good to know about integrals, I guess. Oh my god, I okay. I feel super scatterbrained right now. Um so yeah, color cone. What's happening here? We've determined that this integral Uh, it can basically get you the coefficients of a Fourier series. So they never can be written in terms of Fourier coefficients. Right. Can you pause it for me? Health gonna be way better. Over here it's shit. Couldn't get all the stuff I needed. Prices are through the roof. All right. I'm glad you have that to look forward to at least. Banger song? I didn't even recognize this. Slow Dancing in the Dark by Joji. Maybe you meant the last one. Yeah, I've hardly been to the East Coast. It definitely has a different vibe than the West Coast. This one? Okay. Can we do that for P sub R? When am I coming to Europe? I would love to go to Europe. Probably not for a few years. Like I need to graduate, get a job, save money again, and then once I have some savings, I can hopefully take a sabbatical or something and just enjoy life for a while. But that does rely on me getting like a well enough paying job to be able to do that. Um, so we need to write this as the inner product of something. Um, so it's the inner product of PR. Uh, RE to the I beta minus T. What is happening outside? It's like someone's pouring gravel onto concrete or something. Oh, it's going again. Okay. I might have the argument of this wrong. Weird enough, this will be the last two states that will have visited in the East Coast. I visited every East Coast state besides Connecticut and Rhode Island. Wow. I've been to Delaware, and then as a kid, I've been to Pennsylvania, and that's about it. The derivative integral inverse relationship is not fully realized within Riemann or Lebesgue integration. We need to find notion integration to recover it more completely. Yeah, that's kind of the annoying thing. So I don't know what those finer notions of integration are, but I'm sure that they exist. But I don't think with Riemann integrals, the derivative of the integral isn't always the same as the integral of the derivative. In fact, it actually, well, because of the constant, it never actually is. Well, not necessarily, at least. It's up to a constant, they could be the same. But even then, you can throw like 1 over x cubed at it and break things. Or sorry, just x, not 1 over x cubed, x to the 1/3. Sorry, this background noise is going to be the death of me. I don't think it's coming through my mic, thankfully, but someone keeps pouring something. certain types of noises just really get me. And that's that type of noise. Oh, this is a Radiohead song. This one, it's catchy, but it's really like cringe is the word that comes to mind. West Coast to see Nevada. Ooh, Nevada's cool. I've only been as a kid though, not recently. So you always do definite. That's fair. Oh, I don't have the song request turned on. I'm not doing it through Nightbot right now. But just for you, Obi, I will go and add that. Jason Charles Miller. Okay, it'll play after this song. Hey, Lillian, you never seen hieroglyphics like these? Sorry. Welcome in. The background is I'm an applied math master's student. The theme of the stream is I take questions from chat and do my best to answer them. If I don't have a question from chat though, I do homework, and my homework involves this complicated looking math. If you have something you want to talk about though, please do let me know. But when there isn't something specific to work on, I do this complicated looking homework. So sorry. Of Den Joy integral. Well, let me Google that. And I'm still thinking about how to write that as a coefficient of a Fourier series. So Nightbot does song requests. I'm not currently using it though. So that Obi's like command went through there, but the song wouldn't actually play. Oh, that's JCM. Wow. I didn't. That's cool. Yeah, right now it's a scam. I sometimes have them turned on though, and I usually will pin a message in chat. I haven't done it in a while. If you just want me to play a song though, I could always add it also. JCM is Jason Charles Miller, I guess, who apparently streams on Twitch. And that's his emotes right there that Obi put. That's the song we're about to listen to after this. Inequivalent definitions. That makes sense if it's a, yeah. We say that naturally gets easier as you age, or is it more like a situation where you have to keep studying more and more to understand? Like math? There's two ways you could think of this. I think it's easier, like kids are sponges. They're really good at learning. And so in that sense, I think it might be easier if you're a kid, as long as you can like motivate yourself to want to learn it. The other way of thinking about it is that I do think learning math gets easier the more experience you have learning math. Like just learning math itself is a skill. There's also a trade-off though, where you're also trying to learn more complicated things that are more difficult to understand. I don't know, that's a really good question, Lilin. Um, I don't have like a good answer for it. Definitely like I need to spend more time on things to understand them, the more difficult the math I'm trying to learn is. But there's also other things where I can just like Like maybe it's like a trick in single variable calculus I haven't seen before, but I can understand it pretty quickly because I'm so experienced with other parts of single variable calculus. So I guess it depends on what exactly you're studying. What was a math term? Oh, okay. Was someone struggle with math at high school? Hey, Famished. And thanks for the follow, Lilin. If you struggle with math in high school, it's like, it's never too late if that's what you're asking. There's a lot of resources out there. Well, everyone knows Khan Academy, but there's plenty of lectures on YouTube. There's let me find it. In the Discord. I have this helpful resources link, or like a channel. And so like if you are looking into high school math, MIT OpenCourseWare might have stuff for that, but there's also OpenStax that has completely free textbooks at that level. There's 2 pretty big math help discords plus my stream and Twitch math streams in general. It's actually, there's been quite a few new faces today, and I haven't been shouting out the rest of the math niche on Twitch. I've been slacking, but yeah, for anyone who's new to the Twitch math community, it's not just me. There's plenty of us out there, and Simplex Pachinko, who goes by Obi-Wan Pez. So if you hear me say Obi, I'm talking to Simplex Pachinko as a fellow math streamer, and there's a whole list of them here who I can generally recommend. But yeah, so TVSR8, it's never too late for someone who struggled with math in high school. If you have a specific goal in mind, feel free to let me know and I can maybe say something more specific, but I think anyone can learn math. For some people, there's like an element of natural talent where like some people it just comes easier to than others, but I think if you're willing to spend time, anyone can do it. It's not always worth it for everyone, but if it's something that you want to do, you can accomplish it. That was it this whole time, yeah. Learn math, that's what I'm doing. Yeah, Famish has been studying hard. Well, do I do study sessions too? Not specifically. That's kind of what these streams turn out to be. I don't specifically do like study sessions where like, I imagine something where it's like more like a co-working stream where I'm not paying much attention to chat. I don't necessarily do those. So I like talking to chat too much, I guess, and interacting with people. But the some of the streams in that list are like study streams, like the last part, like Ren, Math Spellbook, BizBuzz, and Suna. And there's even more streams out there than just them. True of Slight League may need to help figure out where your hangings are. Yeah, that's fair. Does Obi's name get censored in that list for you, Raven? That's kind of annoying. There is a profanity, yes. Okay. Oh man, okay. Yeah, because there's the profanity filter in the chat settings that you can turn off if you want. But it's kind of annoying that for everyone else it's going to be censored. Who doesn't do that? But yeah, it's a really unlucky thing with Obi where it starts with CH. There is technically a bad word in Obi's name, but like it's clearly like it's clearly N-Simplex Pachinko and not saying anything else. So, but the Twitch automod doesn't know that. There are different types of math you see in school, just calculating things like algebra, analysis, calculus. Wow, the automod actually, that's crazy. Famished. I had to approve that message in automod. Calculating things like algebra, analysis, calculus, linear algebra, geometry, doing things with triangles. If one struggles with one of them, one may not necessarily struggle with the other ones. Yeah, that's true too. Depending on the type of math that you're studying, different types of math come easier to different people. GPT itself as an alternative. Yeah, I wouldn't trust ChatGPT with everything, but it does have its place. Oh yeah, OpenStax is great. They'll take you all the way through like middle school through high school math, and I think maybe first year university even too. No, it's the entire part of Obi's name, including the ch and after. Or I'm sorry, no, it's not the entire part. From C to K in pachinko is the bad part. And I'm saying that for the benefit of people who might not speak English as their first language. Like, it's not a good word. If you want to know what it means, look it up on Google or Urban Dictionary or something. You don't understand why other users can't see a message if it was held. Well, that's the point of holding a message, right? Suck now, it might be offensive, so they don't let other people see it besides mods. No, Obi's name is fine. It's just the auto mod. Branders from ChatGPT style of writing. It can be a little extra. Okay. How is this a Fourier coefficient? It's weird because this is like, oh, this is the thing where theta is going to have to equal t. But yeah, I don't know. Yeah, Max, that's a good caution to throw out there for ChatGPT. Like ChatGPT never says I don't know, so you can't trust it as far as you can throw it. Like always verify with another source that's not AI. But like I can't deny it has its place. You have 3 AI apps. Oh, nice. You don't know about the word? Yeah. No. Pachinko is a word that's completely fine. And it's as you say, a game like that. Um, but in the word pachinko, take the letters from C through K, and that's a slur for Asian people. So it's like a subset of pachinko, not the entire word. It's an AI that builds projects. I have not heard that. No. I want to compute in. Um. Oh right. So I'm taking f equal to 1, and that's why you're giving me that example with putting equal to 1. Um. Sorry, TVSR. Pachinko is not a slur, but delete the P, A, and the O, and you do get a racial slur. I'm trying to like dance around it. Like I wish you could just say the word for the sake of like just educating people to not say it, but Twitch isn't that understanding. So that's why I'm dancing around it and trying not to say it exactly. Um no worries. But rainbows, that's funny. Yeah, the people who have like yeah, that is always super funny when they have a profanity filter that swaps out bad words with like friendly words. Yeah. What is that name actually? I'm not sure what you mean by that, Raven. Okay. I'm getting confused. Uh How do you know what the Fourier series of this is? Kill that summation? I would love to kill it, Phobos. You always have that bloodthirst. Actually, you know what? Well, let me get out my red color. Gah! Gah! There's another one. Gah! Oh, also there? Can't forget that one. I'm just doing what Phobos tells me, I guess. Blocks, hey. Phobos demands blood. PR theta. Yeah, okay. I'm sorry, Color Cone, that I'm like not paying full attention to what you're saying here. I can't handle letting a chat message slip by. What are we getting banned? Never, never. Oh, okay, so it's R to the 0? Wait, so how do we know what, or why is this the Fourier series for this? Don and Zach are both having trouble keeping up tonight because they're multiple threads. Yeah, they really are, Obi. One day you'll get it, Raven. It's usually the definition of Poisson kernel. Well, we were just given the formula. I would need to justify that somehow. The fish kernel, exactly, Dojo. Hey, Max. More distractions are always welcome. D by dx x transpose bx is an r n by n. So I don't know enough. Like, I actually do really need to learn how you do this problem. I don't know how to do it myself, though, to be honest. The only way I know how to do this is to literally do this multiplication. Like, actually name all of these elements and then take the derivative afterward. Well, actually, this is derived with respect to a vector, though. So that won't even work. That only works for partial derivatives. Hey, Winklebutt. With the Jacobian? Right. So that's like vector x. Like, these are all like vectors, I guess. Can you do it using Euler for me? Don't remember it being very complicated to derive. Okay. So yeah, I actually need to learn how you do this type of multivariable calculus stuff. I don't know how you do this though. If you want, you can post what you did, Max, but I don't know. You haven't thought about the circle problem a little? You don't have an answer. Oh yeah, so that homework was already due, so I made an answer and I submitted it. Doing it after last time, you think you have the answer? Spoiler alert, I'm going to show what I wrote as the answer for this question. Bam. Almost done with Calc 2. Can't wait for Calc 2 and linear algebra. It'll be a nice break. Ooh. Okay, Calc 3 and linear algebra. Yeah, Calc 2 is kind of a pain. Calc 3 and linear algebra can be pretty fun, though. It always depends on the professor, but those are both really cool topics. That's what you got too? Oh, nice. See, I don't understand. Like, this was given to me by the TA, basically. I'm really terrible with probability. But yeah. Your result is it's equal to x transpose b plus b transpose. Interesting. Also, that's to show convergence for Ramanujan's formula for calculating pi. Oh my god. Oh wait, that actually might not be so bad if it's the one involving arctan. That's one thing that looked really complicated, but no? Okay. In Ramanujan, I had like a bunch of them for calculating pi, I thought. Oh, it's just showing convergence. There will probably be a ratio test in there. Oh, okay, yeah, that's fair, Max. That's what I did for a problem on our previous homework assignment. Just use a lot of dots. Right, I had to do a similar thing. Yeah, I haven't studied that type of calculus though. I'm feeling the pain of not knowing it now. To get good probability to get good at probability takes an undue amount of time working on probability. It really does, Dojo. Oh my god. I don't know what this is. I mean, okay, if you're doing this, that looks terrible. Yeah, that was my solution. I can show it again if you want to see it. I'm sure a ratio test will make all of these go away, or it'll give you a lot of cancellations, but it would still be really intimidating. And you have some big numbers to like deal with. Yeah, definitely if I had that on a test, I'd be a little like, oh, come on, really? One of the fastest converging approximations. How interesting, Hui. You've been learning Russian. Ooh. That's apparently a really hard language to learn. Are you learning it because of chess? That's my best guess for why you might be interested in learning that. Yeah, I don't know for myself. I just heard it's a really like subtle language. Zdravствуйте. I'm not terribly picky. You can put it in math discussion if you want. There's no wrong answer, though. Um, I know, I'd like to make this integral thing actually work, but I guess I made a mistake somewhere. Four k factorial over k factorial to the 4 is less than 4 to the k. Okay, that's the one thing I was wondering about when I was looking at that series. That factorial might be a little bit tricky to get a cancellation for. Less than 4 to the k. It's for math. Ooh. Yeah, I mean, that makes sense too. That I'm sure there's a lot of like Russian math textbooks. Math for computer sciences, we just did the simple basics of what a Jacobian is. Now in foundation machine learning. Did not talk about this in lecture, had to do this in... Oh, that sucks, Max. That's basically what's happening to me with my PDE class. We're just expected to know this multivariable calc that I never learned. In addition to measure theory and functional analysis. It's really frustrating to be in a situation like that. And honestly, that's not a bad time to use AI. At least to get a start. You didn't hear it from me, though. This is the other one that Winklebot was working on. That's kind of a funny one. It has pi to the 2n. This is going to be another... Oh, determine the sum. It's not just convergence, but the sum. Huh. There must be a... Like, there's a geometric series sort of in there. I assume it's going to be 0. Like, a series is complicated, I think it's just going to go to 0. It's alternating. That's kind of difficult, though. Oh, they did end. Thank you. Let's play the song. N equals 0, so the first term was 1. Makes sense. Wait, does it make... Yeah, it does. It's like cosine. True. It's like cosine also with a geometric series. That's a great call. Wow. It's just cosine? Evaluated as... Oh! You haven't done power series? The hell? I don't know. It's just cosine evaluated at pi over 6. So it's not even 0. It's really short. Wow, that's such a great spot, color cone. Unit circle? Root 3 over 2. How do you do that without power series? The song. I said another whole language just for maths? It's a good question. Honestly, I could kind of see the incentive to it. It'd be kind of cool. It's like it's a good excuse to learn another language, I guess. Like, it's cool to know another language in general. So if math helps you get motivation, then why not? And Colorcone, I'll go back to what I was trying to show in a minute. Sorry that I'm all over the place again. Uh, sorry, I'm reading through chat. I don't mean to be ignoring people's chats. Um, partially for maths, partially for yeah. You might have ended up just at you end up just estimating it. That's fair. Having the feeling of self control. So hi, Lothric. You already speak three? Well, yeah, Dutch, English, and what's your third? No, Winkleμπot, you never need to apologize. Quite a pickle with your feelings. Francois, ah, nice. Um, French, German, Russian are the requirement of the math department in one universities. For math? It's not for Francois. Sorry, I'm dumb. Oh wait, oh Francois is French or like a French person or something. I don't know. Francais? I don't know French. I'm sorry. I try to be cultured and I'm not. Francais. That's really interesting that a math department would require that. Francois. Okay, that's fair. Okay. Sorry. Color Code asking what I was trying to show. Let me go back to that. And Color Code, if you just turn the stream off because you're frustrated at me for always skipping around, I understand. Uh. Also, you probably learned Galois theory. True. Gotta read it in French. Okay. I wanted to actually do the integral and get 1. The issue is I did the integral and I got 0. You're not okay, but if you ever do, I understand. um French isn't high school, but yeah, that like even if you're not fluent, I still have a huge amount of respect for that because I'm not even slightly close to being able to speak another language. They dropped the language permanent a while back though. Okay. Hey, Dessen. Salute don comen es salute me on my journey something? I don't know. Yeah, it's not necessary, I don't think. Especially today with like translation software. I think it's more of just like historical interest and just like wanting to learn another language in general. You can learn all the math in the world just knowing English, though, I think. Half my faculty can read French, half the department is doing algebraic geometry. Fair enough. How am I doing on really? Wow, that does not even look like the English words for that. I'm doing well though. Yes, that's I know that. How I know that's how am I doing? Estoy bien, E2. French is super great. You're taking French when you go to a 4-year? Nice. Okay. Grafton had such a big impact in the field, and needed to keep to people to read his paper written in French to keep up with the field. Oh, interesting. That makes sense. How's my daytime? Daytime is doing great. Actually, the weather today is nice, depending on for most people's definition of nice. The weather is nice. I honestly like rain, but it is like a sunny day out now. Yeah, I that's what I assumed too, Lucas. So it looks like the word journey in English. I was like, oh, okay. Maybe he's talking about my journey through math. Um, how do you actually say that? Journée? Let me. I want to hear the Google Translate lady say that. Go away. And this always makes me giggle. I don't know why. It's just journey. I don't know. Okay. Which country has the best math culture? That's a fun question throughout history. Like France, Germany, Russia, UK. I mean, Greece, if you want to go farther back in history. Switzerland is being carried by Euler, but yeah. That's a tough one. Like, if I was just guessing off the top of my head, I'd probably say France, but that um okay. Calico, you're gonna go do your groceries. I mean, hey, if you are gonna stream it later, people here should go hang out with Collar Cone. Um, who just got 6-7 followers, by the way. Oh, Bernoulli's too. That's a good call. Um, if they're so important, shouldn't they be translated? I'm sure they have been, but I think like they don't get translated immediately. I don't know. Also, Grothendieck was active like 19 like 40 to 60 ish when translations were a lot like slower to come by. Learning language for basic communication can be kind of hard. Being able to study math or anything really in it is more difficult because you need to know all the jargon. True, yeah. Middle school, high school, year in college, they wouldn't take the junior level classes of gen ed. You wanted to date a French model because you liked watching. I don't know. I'm gonna try to pronounce that after I messed up Francois or whatever. The Bernoullis are Swiss. I'm pretty sure. Because actually, I was just my PD's professor was talking about how Euler was childhood friends with the Bernoullis, and Euler was just an all around like smart dude trying to decide what to study in life, and the Bernoullis got him to study math. Apparently, I don't know if that's true, but that's what he said. So is your 5G is on all this time? Oh no, Lucas. If you remove Göttingen, Germany is out. Jargon is a weird word. It kind of is. Modern history is considered historic. Then US wins. That's fair. Depends where you draw that line. Yeah, I think different countries have had their eras. Because, like, if you go back far enough, like, Greece just wins. I mean, I also just don't know that much about China. Like, I think China was doing a lot of math, but we just never learned about it. That's really funny, Obi. The Wikipedia subcategories for Swiss mathematicians by century: Republic of Geneva, Swiss women, Euler gets his own, Swiss historians of mathematics. There is it's the same word. Wow, that's interesting. Okay, publishing works from our 80+ year lifetime, 47 years after your death. I have claimed to be the greatest mathematician. Fair. Wasn't going to shine, so we moved to St. Petersburg, right? Or it's a German princes. I have not read that, Pui. Yeah, Archimedes is like my history of math professor during my undergrad said he's in the running for best mathematician of all time. And I don't know about it for myself to like comment, or like I don't know enough about the history of math for myself, but like he absolutely scratched the surface of calculus like 1,000 years before Newton and Leibniz discovered it. Fully. I don't know if it was 1,000, but like something like 1,000. He's absolutely limited by his time. Netherlands was at one point the strongest country in the world. We'll never forget that. I mean, I wouldn't either if I was Dutch. The YouTube Shorts music. Oh, is it? Like, Air World invented algebra, spherical geometry, solutions to polynomials. Ooh, okay. Japan SDE invented because of their work in the field. Oh, maybe. I couldn't name. I don't know much about Japan's contributions to math. I'm sure that they've done a fair amount though. India did a huge amount. I couldn't name anyone really outside of Ramanujan, but he is like a huge figure in math on his own. Easily Grothendieck, not even a discussion. Sloan Golden Age get a bunch of their math from India. I don't know. Yeah. Math history is really cool, but I only know like bits and pieces. First IMO is China. Picked up a lot. They also invented a lot on top. Yeah, because like again, I'm just repeating things I learned in my math history class. He described the Middle East as kind of like preserving other cultures' works, but not necessarily doing that much on their own. I don't know if that's accurate. But that's how it was described to me, at least. Brahmagupta. Oh, I have heard that name. Bhaskara, I don't remember. To understand Euler's letters on mathematics of music, most. Oh, I did. Okay, yeah, I remember that. Pooey. I think I read that on his Wikipedia page. Arabic numerals are actually Indian numerals. Oh, I think I've heard that, Winklebot, yeah. And great mathematicians in almost any country. Oh, yeah, it's absolutely true. Lothric. I tried to be careful not to say that, like, someone from a certain country can't do math. I'm just trying to think of, like, historically who have the biggest contributors been, but, like, there's absolutely nothing about the origin, like, prevents someone from, like, being able to be a great mathematician. When you finish where you have to read Euler's music writing, since your initial area study was Western music theory. Hey, there you go. Like, I should drink some water. I've been talking nonstop for like an hour and a half, I feel like. 1 second. Wait, why didn't my mic mute? Okay, I feel like I should say thanks so much for everyone who's been here and been chatting. I'm not used to having a chat this busy, and it's kind of a lot to keep up with. If someone is here because they want to watch math and I haven't been doing math, I'm sorry. I'm not used to trying to keep up with like, with this, so I'm just doing my best here. Same engineering is a good set of lists. Okay, call yourself remembering so many people from so many countries. Their contribution is indisputable. Yeah, I mean it's something like a collective thing that all of humanity has contributed to. Strongest is America, even though American students don't know how to solve quadratic equations. Yeah, your average American student becoming a real streamer. I mean, I've had days like this before, but they're not often for me. These are biographies for like every mathematician. Where's all the ones that they? Where's Algebra? I don't see him. I don't know. How about Euler? What do they have about Euler? Oh, we haven't talked about Euclid either. I mean, Euclid apparently plagiarized a lot of stuff. This is a cool thing, Obi. Oh, birth countries. Yeah, we should look at this. Al-Khwarizmi. Oh, okay. For algorithm. Oh, okay. It wasn't his name. It was the name of. It was this algebra is where we get algebra from. There we go. I thought it was his name. Are American undergrads known for it to be abysmal at analysis? I think most are. We usually emphasize calculations in applications over analysis. Yeah. Weren't there any important Spanish mathematician in history? I feel like I couldn't name any, but there's got to be someone. And this website is like the perfect thing to find out the answer. Spain. Oh, hey, I mean, the answer is probably that there are. Do I recognize any of these names? I don't recognize these names so far. Okay. Yeah, no, but like, this is something you could look through and see what they've done. Like, Vigneault? Oh yeah, Obi, please do. I was specifically not pronouncing names. I guess I did just say Vigneault. There's two of them. I don't know which one. Germany had Euler. Well, Euler was Swiss. Gauss, Riemann, Hilbert, Klein, Dedekind, Weierstrass, Noether, Weil, Hausdorff. It's hard to compete. Germany's definitely a big one. Erdish? Where is he from? Latin is also probably a big barrier to reading Euler's music writings. Oh, he wrote in Latin? Wow. Spain is strong for algebra. Oh, cool. Some girls tied to Spain. Yeah. Spain is really um multi-ethnic, if that's the right word, or like diverse as far as I know. Hungary. Oh, okay, okay. I feel like is there someone from Turkey? Uh, oh, they're like ancient, yeah. But I feel like never mind. I mean Egypt. Like ancient Egypt did a lot of good math. I don't know about like more recent African countries, but I wouldn't sleep on Egypt. Yeah, I was curious. I feel like there's also some significant mathematicians from Turkey, but apparently not semi-recent. Only if you go back far enough. And I know Hungary is different from Turkey. My brain just went to Turkey for some reason. I think I thought that Urdish was Turkish, I guess. Um, I want to know, when was Laurent alive? Because one of my professors made a comment that's uh made it sound like he was more recent than I would have thought. No, 1843. Okay, never mind. There's a great school, especially in combinatorics. I did not know that. Okay. Um, After having this conversation, I feel like my brain's been flashbanged, and I've just like forgotten everything that I've learned about PDEs now. What do I want to work on? I kind of don't want to work on this question now. Me, I don't want to do question 4 either. Poland. I bet Poland will be good for math. I don't think I can name a Polish mathematician though. Okay. What about from problem 3? What about this middle sentence? Say problem in the upper half space, the formula from problem 2, which is this right here, implies that if f is compactly supported, which is an interesting requirement, the maximum can never be attained inside the upper half plane. Sounds good, Winklebot. Thanks for hanging out. Kuratowski, but Banach, I know that name. Stanislav Ulam is Polish. Okay. Banach, Sierpinski, I know that name. Tarski, I know that name. Kak, I know that name. Okay. That that is a lot. You know, actually, I kind of want to save that link that Obi posted because I really like that website. Actually, I'm gonna put it in the math resources thing that I was showing earlier because it's kind of fun. What is this called? Biographies of mathematicians throughout history. Okay. I mean, the great thing about this website that Obi showed is we can just take a look at Poland. Here's Banach. Copernicus. I didn't know he was Polish. That's cool. Courant sounds familiar too. Fuchs, maybe familiar, but I think I'm thinking of the show Barry. I might know the mathematician Fuchs, though. Hausdorff, yep. Grassman kind of sounds familiar. Heck, maybe. Hopf, I think. Hopf, Hausdorff something is a name of something, I think. This list is long. Kronecker. Wow, that's a big one. Lasker. Wait, isn't this a chess player? Oh, that's kind of sick. Both a chess player and a mathematician. And he had... Oh, wait, no, that's not a monocle. It's just... Never mind. Is a group theory theorem? Oh, cool. I'm not going to be able to pronounce that right, but Evenique? Already an analytical number theory? Okay. Mandelbrot? Yeah, Poland is a good call. They're kind of sleeper have contributed a lot. Ronsky. I do remember that. Yeah, he was really aggressive, right, in chess. Mandelbrot was half Belgian. That's still half credit. Hey, Orange Hue. This is a really fun way to organize mathematicians. I like this a lot. Oh, that's cool. You just have a world map? There's so many in Europe. Holy crap. Well, it's like even regions you can narrow it down by. This is using the names for the countries that they call themselves? Deutschland, Polska. Interesting. Any American methods from 1500 to 1800? Probably not. I don't know, Max. I saw that too. Same with the group theorists. I wonder if there's something... I don't know. Oh god. I mean, I am curious who is in the USA, but probably never Orange Hue. I doubt I would do anything important enough. How long is this list? Oh, this is very long. To be fair, this is made, I assume, by... Oh no, it's... This URL is from the UK, so maybe it's a British university. I was gonna say that if they're an American university, they're probably gonna be more likely to list Americans than they would be non-Americans, but I guess not. Yeah, they're in Scotland, so never mind. Yeah, UK is better to say than British. I mean, there are 1800s, but yeah, before 1800, not much. We were too busy dumping tea into the ocean to do math back then. Thanks for sharing that, Obi. Any Russian mathematicians before Euler moved there? Probably. Dude, we could probably spend an entire stream on this list. GP Bear, thank you for the 100 bits. I appreciate that. What can I tell you about continuous fractions? A little bit. Temporary. Okay, wait. So, let me look at. Ben, there's a few things people are asking me to check out. So, GP Bear, I will talk about continued fractions. Let me look at Benneker. I'm in the wrong list. Oh, Banneker. Astronomical Almanac. Son of a slave. Grandmother was accused of stealing milk and condemned to death. Sentence was then reduced to being sent to the British colony in North America, which eventually became the owner of a farm and married one of her slaves. Wow, that's a wild background. At 22, he made a clock from wood using a pocket watch he borrowed as a model. Wow, and it continued working for the rest of his life. That's cool. Okay, this is a little bit longer than I want to read right now with all this going on. That's a pretty cool like backstory already, though. Where they pretty much founded math culture in Russia? Oh, I didn't know that. I assumed that they just always enjoyed math. Okay, so GP Bear. Continued fractions. It's kind of a funny way of representing numbers that are otherwise like you can't represent them with just like a regular fraction. And you can, I'm pretty sure you can always define them as like a sequence of numbers. So like but these can lead to some kind of cool representations, I think, for certain numbers. So I guess maybe before it could be getting me a little bit complicated. So let me just say so we're on the same page. An example of a continued fraction that's a little bit easier to look at, but not much. I don't know what this would be equal to, but if you had like 1 over 1 plus 1 over 1 plus 1 over, or like, and this like goes on ad nauseum. I'm pretty sure you could solve what exactly this is. I don't remember offhand exactly how that works. That's like, and actually, I think maybe it's interesting if you make this 2. I forget, but or there's a 2 involved somewhere maybe. But yeah, you can often find that like, I don't know what this one will be equal to, but like root 2 or pi or something like that. You could also express this as, I said, like a sequence where this is equivalent to an is equal to 1 over 1 plus an minus 1. And then you define a0 equal to 1. And so that means like for n equals 1, you'll get 1 over 1 plus a0. Which is 1 over 1 plus 1 is a half. For n equals 2, this is, I'll stop after this. It'll be 1 over 1 plus a sub 1, which is 1 over 1 plus 1 over a plus a0. And that's kind of, as you go up in the ends, like this pattern will like reveal itself. And sometimes this is something that you can actually solve. I don't remember how you solve these type of recurrences. We could try to look for a pattern in this though. I feel like this should be something that we can probably guess what the solution is. 2/3. Is it going to be? 3/5. I wonder if this is going to be 1. I don't know. Yeah, right. So you can make fractions for e and pi. I'm trying to remember how you solve these. I've done them before. But not in a while. X equal 1 plus 1 over x. Oh, that is like the dirty trick with recurrences, right? You assume that if it does converge, then for some big enough n, these two numbers will be the same. So let's just pretend whatever it goes to, we'll call it x, as Max says. And then we can just solve this as an equation for x. Because these two numbers, we're assuming that they become the same thing eventually, or close enough. So the point where we can just give them the same name, x. It would be x squared plus x equals 1. X squared plus x minus 1 equals 0. That's not the golden ratio. What is this? It's nearly the golden ratio. It's like some conjugate of it or something. Or like it's like the golden ratio plus a constant, I think. Because I think it should be positive 1? Or, I don't remember. If you can use continued fractions instead of Cauchy equivalences or Dedekind cuts. Oh, I couldn't tell you that. Negative is right? Oh, this is the golden ratio then. Okay. Oh, okay. I wonder if there's a different way that you can get this. Because this is like, it's a little bit of a dirty trick. Like, you should show that the series converges first before you do this. No, that's a positive one. I think it does have a partial, it does have a, oh wait, what the hell? Am I bad at math? The answer is yes. The continued fraction is the same? I think I did something wrong. I got the negative of phi if I take the minus solution. I don't know, there's something about this that's slightly off. But yeah, I don't know if there's a general way of doing continued fractions. Let's look for a non-Wikipedia resource. I don't want to do this. Let's get irrational numbers. You also have phi equals 1 plus phi equals root 1 plus root 1 plus root 1. Ooh, like an iterated square root divided by, I don't know, times? Or, okay, I assume you're showing some work there or something then. So phi is also equal to the like the continued square root. That's pretty cool. Okay, you know, this is too complicated. So, if ooh, okay, that's kind of cool. So a continued fraction only terminates if it's a rational number. That kind of makes sense. I'm not. The song requests aren't on. I can manually add that though. Los testeos. Mucha. Okay, it's in queue. Actually, who cares about Lana Del Rey? We're gonna skip this song. Um. Oh, you can kind of compute it in a forward way. I wonder if you can get it backwards. A continued fraction expansion of R is eventually periodic if and only if. Ooh. So the continued fraction for pi and e aren't periodic? That's unlucky. I thought that they would be. So is the difference being transcendental? No, because cube, it's not. Yeah, but that's so weird, Hui, because as you say, it's square radicals. A cube root wouldn't be periodic either, I guess. Huh. I didn't know that. Oh, you can set up an equation like this, I guess? If you assume that it has a finite end, and then take the limit as k goes to infinity. Okay. So yeah, I don't know, GP Bear. If you have something so you want to ask, feel free. But um, I don't know. I haven't done that much with continued fractions. I've only kind of played with them a little bit. Okay, I'll add that one too, Destin. But I'm doing this manually, so it like it's not using the Nightbot, so I don't want to add it anymore. Without you, it's okay. See, you do have some banger music taste. I should just actually turn on the song request if we're gonna do this, but right now I'm using Spotify. Oh, that's what you mean, Pui. Okay, okay. Or wait. Okay, yeah, I think I understand what you mean. Okay. Um. So yeah, GP Bear. I'm gonna leave it here unless you say something more, I guess. Oh, that's kind of cool. The 22/7 approximation for pi, you can also like find it organically with um continued fractions with a hot pocket. What kind of hot pocket? Hard to type math on your phone? Oh yeah, I bet. Oh, you're even getting the Greek letters in there in the square roots. That's even harder. Sounds good, Max. Thank you so much for hanging out. Sleep well. I keep saying it, Pooey, and I never do it, but at some point I want that chat box or that chat box up there to render LaTeX. Um, it's something I'd have to make myself though, and I really don't want to take on that coding project right now, and I've been wanting to do it for like at least 2 years now, and I just haven't done it. Okay. Um, Calcun, you'll be happy to know I didn't make any progress at all on the PDEs homework because I've been distracted. You had a Greek keyboard, only be able to type letters for equations? Oh, that's so smart! I never even thought of that, Lothric. I have like in the about section below my Twitch page, at least if you're on desktop, um, I have like a bunch of math symbols like typed out there so people can copy paste them. But the Greek keyboard is such a good idea. Oh, does Aleph have that? I follow him. I never have watched his stream though. My hot pocket counts molecular cooking. I mean, I guess that's what a microwave is. Um. Oh, you even have a VOD. Okay. An extension for the browser. My peepee. Uh. I think that looks like it's rendering the LaTeX up in there. They're not making the LaTeX right, or like that's cool. Like for me, I'd wanted to do YouTube chat also. I assume this doesn't do that, but maybe it does. That's cool though. I didn't know someone had already done that. I'll show different keywords after you add them. Okay. Extension for the browser. I mean, I could just have an application that displays Twitch chat with the rendered LaTeX. That was my idea for it, at least. So phone and PC, you'll randomly press buttons trying to guess where the right one is. Oh yeah, fair. You added the Hebrew keyboard to type a left 0 once. Nice, ADS. Don't know if it's open source. That's fair. Yeah. He could just like want that for himself. I don't know. It's on GitHub to do that. It's old and broken. Okay. No, that won't work, Dessen. We're looking at a different person's stream who has apparently. Oh, I what? What did I get wrong? Is that an I? Oh, it's VT, not TV. Never mind. There we go. Okay. What am I doing? I mean, is he actually streaming? I wasn't planning for it to stream for much longer. But Colorcone, if you're gonna actually plan to stream tonight, if it's gonna be anytime soon, you need to eat your hot pocket. That's fair. Yeah, no, but that's fine. Take your time. But yeah, I left Mew isn't streaming if that's who you're talking about, Dessen. Okay, but yeah, you have a raid coming your way whenever you're ready. No rush, because I can keep on working on this PD's homework in the meantime. At least trying to work on it. If F is compactly supported, the compact support of F. A gravy? That sounds disgusting. Out of a hot pocket. So if F has compact support, we can reduce the integral to some finite interval. Now what? I mean, we could bound it above by the maximum of F. I don't know if that's good. Like, I think I feel like we would want a strict bound, but I can only the best I can do is a not strict bound right now. Well, okay, we could still do this and then and then something. MMP? Mean something property? Or maximum something? I don't know. What does this become on a finite interval? Oh, maximum modulus principle. Okay. I'm used to calling it maximum value principle. The hard times will begin to fade. Joy will take their place. Ooh. Yeah, acronyms. They can be annoying. Yeah, that does sound nice. Um, a light heart carries you through all the hard times. Ooh, that's a great fortune. Technical English writing is all about to express everything as a three-letter acronym. It often does, yeah. Oh, and you know what, Femlox, there's another really cool thing I learned about uh yesterday in class. One plus oh, that's the square of a number, isn't it? When you sum odd numbers, you get some other number squared. I forget the relationship. Uh uh I'm gonna guess 169 just for fun. I don't feel like actually calculating that. You also put a kappa there. Um yeah, Felix, we just learned about energy methods, and I want to. There's a really cool thing. With how it connects to what we were doing for general relativity, Laplace's equation. 28 squared, maybe. That's half of 57. I'm gonna refund it anyway because I didn't do it quickly because I'm lazy. That seems about right though. Mr. Factorial. Do birds of a feather calculate Laplacians together? 6-7. Oh, if it is 6-7, that'd be great. Okay, so if you remember from calculus of variations, the question of calculus of variations is often, or like the basic question is, if you have an integral that looks, well, if this is your energy and u is a function, if you make a particular choice of the inside here, 1/2 gradient, magnitude of the gradient u squared minus u times f. These are functions. I should and this x is a vector. Ugh, I should be more specific. U maps Rn to R. F maps same thing. U of x times f of x dx. Dirichlet principle. Yeah, that's what we learned about. Oop, and this is a minus. So like it's a common calculus of variations question to ask, like what function u minimizes the value of this integral, because ultimately this integral is just a number. So what u gives us the smallest number? F of x is, as we're just given that. And it turns out so this is something you could do with like Euler-Lagrange equations. Oh my god, I can't follow the math now. Damn it, I understood it at the time and now I don't. There's an integration by parts that you have to do. But basically you can get that the optimal u you consider, you do the calculus of variations thing where you consider if u is the true minimizer, you consider some small deviation from u. In this case, phi is some variation function and t is just a scalar that we're going to send to 0. The visualization of a homology of a torus? I'm okay. Add a math dictionary command like dictionary and random math words spit out. Ooh, that could be fun. 6, 7. I might do that, Dustin. Maybe I'll make it like a channel point thing, like the fortune cookies. Man, okay, I'm sorry. I'm gonna drop the ball in this explanation. I thought I had understood it better than I actually do. But u plus t times phi, just for some variation from your true minimum, you can show that the optimal u is going to be given by this, and if you actually do calculations with that, you will end up with, oh sorry, u actually maps omega to r, but omega is a subset of Rn. You need to do some like multivariable integration by parts, which makes it tricky, and that's the stuff that I don't understand. But you end up with minus delta u minus f times, let me put my of x's and not be lazy, is equal to phi of x dx equals 0, because it's an optimum, and so we're just taking a derivative and setting it equal to 0 to find the optimal u. And since phi is just some arbitrary function, like it needs to work for every choice of phi, this bit here has to equal 0. And so you end up with the equation minus delta u of x equals f of x, which is just Poisson's equation. And so there's this really cool connection where like minimizing this functional here is the same as solving Poisson's equation. And I skipped over a bunch of steps because I realized that they're a little bit annoying. But I know, I thought it was super cool that like solving a PDE is the same as solving a calculus of variations problem pretty often. And as Colorcone said, this is called the Dirichlet principle. You wish you were in that class? I mean, it's a really brutal class, and honestly, overall, I'm not enjoying it. But we do sometimes learn some really cool things like that. I'm refunding that thing that doesn't. Redeemed. The quote command and adding quotes easy enough if I want to set up a custom command. Yeah, it would be a pain to actually create that dictionary. Like the fortune cookies, I just found a list on Google. And copy pasted that thing. If there is something like that for math, I don't know what it is. So I always feel like it's just out of my grasp. Same, Fembox. Like I feel like I need to spend a good like 6 months just learning background information before I can actually learn this properly. Steps are left to the viewer, basically. For consistent problems, it's easy to just use the energy method. If you can show E is bounded from below, has some convexity property or the hypothesis, right? Second, first year calculus, that makes sense. Yeah, I guess it's like finding a source for all that math vocabulary, OB. Smooth functions behave like rational numbers. Yeah, this is Anvil or Lorne. Oops. Yeah, and that's the like I skipped over. I mean, obviously I skipped over a bunch of stuff, but like that's what we've been learning about in my calculus variations class, where like what minimizer you find really depends on the space of functions that you look in naturally. But the bigger the space of functions you look in, the harder the problem is. So there's a trade-off. What's a minimizer? It's a function u that minimizes the integral that I just had on screen. Or like, in general. If you have, like, j is a functional. It takes in a function, it spits out just a scalar number. And the definition of j is, in general, this. The minimizer is the particular choice of y that gives you the minimum j. And so it turns out that assuming y is differentiable continuously is a big assumption, and it's actually really restrictive. If it's piecewise differentiable, then you have some more to like work with. And yeah, like that is a good way to think about like u as like a strategy. Trade the regulator function for a space of functions that is complete. That's the down part. Throw the regulator from that, use some regularity result. Okay. And so like Femlux and I were doing this when we were trying to learn about general relativity. This could be like a geodesic would be an example of a minimizer. So we just did this in C2 color cone. I think the professor said that we're going to get to Sobolev spaces though eventually. But he did in C2 just as like to show how it works. But he said that C2 is a pretty terrible space to optimize in. WK2 is the analog CK, by respective derivative being continuous. The weak derivatives are in L2. Okay. W2K is a Sobolev space? Okay. You say it is a Sobolev emitting. Okay. I don't know what a weak derivative is. I assume it's something that's it's something you could, it's like a piecewise smooth thing where there's just a couple of points where you can't take the derivative. Maybe not though. You hated Sobolev space. My function analysis professor was a PDEs guy. Threw too much at us too fast. 2/3 of the class failed. That's the exact thing I'm afraid of with. Oh. Clonk, thank you so much for the sub. Holy crap, dude. I appreciate you. Thank you, thank you. Yeah, so Megamorph, I'm afraid of the exact same thing happening to my PDEs class. It's a PDEs class, but the professor is a functional analysis and measure theory guy. And he assumes a lot of us, and I'm afraid that I'm going to get to like the first midterm in 2 weeks and just have no idea how to do anything. Sobolev space is the only useful analysis there is besides probability. It's got to be a meme. The idea is to use integration by parts. Derivative in the sense of distribution. Oh, so weak derivative is something for a distribution rather than a function. As your complex analysis class, you know almost nothing about it now. Fair. I'm saying yes to that. I only have strong derivatives. I'm Hans derivative. I don't have Franz derivative. I don't know that reference, but wait. Oh, that maybe sounds a little bit familiar. It's like a workout video. Old SNL. Okay. That's why I don't get it. Distributions act as functions. Yeah, right. And like, I remember like the delta function is an example of a distribution. I sure haven't, Destin. I've been too distracted, and I'm also tired and done with thinking. So I'm mostly just buying time until color cone is ready. I don't really know how to progress in this problem. I mean, if you need more time, color cone, please don't like rush. But I'm probably not going to get much more math done this stream. Just thinking what you're referring to. Erasure by parts lets you define derivative for a dense set of functionals. Okay. A weak derivative computation. I mean, like it could be another day then, color cone, I guess. Lothric, I mean, I feel the same, but color code was great about explaining things to your like level. Like when I first met color code, I felt like really overwhelmed. But like as we like got to know each other, like he started to be able to like know the things that I already know and explain it to those things. Random question: is there anything you enjoy apart from math, like a sport? I'm not much of a sport person, but outside of math, my hobbies are I just really enjoy listening to music. I play video games. I like coffee. Like just like as a hobby, I have a bunch of like different coffee beans in my cupboard right now. I've been to a coffee festival back in October. And then I also just like streaming in general is just its own hobby because I also stream games. Yeah. Like analysis can be realized in algebraic tools. Fair. Cool, some stuff you can do with distributional derivatives or distributional Fourier transforms. You can get that there are weak solutions to PDEs, then you do more work to show those weak solutions are actual solutions. Huh. Math is a sport? I mean, math doesn't need to care about being a sport. I feel the same way about chess. Like, people saying chess is a sport. It's like, why does chess care about being a sport? It's evidenced by us watching it on Twitch? Apparently. Counter-Strike? I hate Counter-Strike. I grew up on Call of Duty. Counter-Strike is everything that I hate in a shooter. You can't move and shoot, and the maps are made of corners. The number one game that I'm playing right now is called Daisy. It's a zombie survival game. That's multiplayer. Oh, I'm sorry. Computer science? My mind is on video games still. Yeah. So I have a bachelor's in applied math and a minor computer science. I know, like, I quote unquote know. It's been a while since I've written any code in them, but like Java, C++, MATLAB, the thing I'm using the most right now is Python. I'm not an expert at it, but I know stuff like polymorphism. I can sort of talk about. I've done like SQL for in like database design. I made a basic website once. Who's spectator chat, Don, or the problem? I mean, this stream has both been me spectating chat and just trying to keep up. So I think it's both of us. This is a friendless community player, so you could. You're live? Okay. Thank you for letting me know, Color Cone. We will indeed wrap things up then. I should have been checking Twitch. Okay. Yeah. Okay. That will be the end of the stream. I'm tired. I don't think I accomplished much of anything today, but it was still really fun. Thanks so much everyone who's been hanging out. The YouTube stream will get cut off here. On Twitch, we'll raid over to Collar Cone. So goodbye, YouTube.